So we'll take one more example so that you will understand that. So we'll take second example, which is okay. So it is entire S-plane. How do you shade that? You shade like this. So it is an entire S-plane. So that is the way how you shade the region of convergence. Because it is entire S-plane, complete S-plane, that fellow would be shaded. Okay, so let's go to the second example. You will see multiple examples so that you will understand this concept thoroughly. Okay, second example. Let us take x of t to be shifted Dirac delta, which is, let's say, delta of t minus 2. Okay, yeah, so how does the plot of this fellow look? It's a Dirac delta function at 2 with the strength 1. Okay, so for this, what will be x of s here? X of s equal to integral minus infinity to infinity delta of t minus 2 e power minus st dt, and you can easily prove that this is equal to e power minus 2s. Why? Delta of t minus 2 exists at 2. You substitute t with 2, you'll get e power minus 2s. Okay, now let us write down what we have got. Okay, x of t is equal to delta of t minus 2. This fellow we got x of s to be equal to e power minus 2s. Yes, Laplace transform we got, but we have to find out this fellow's region of convergence. When will x of s converge? Okay, so this we can write it as what here? 1 by e power 2s. When will this, we'll put a reverse question. When will this fellow diverge? When will this fellow diverge here? If you replace s with, s varies from where to where? From minus infinity to, our s plane looks like this, right? So this is our sigma and j omega. So s varies from where to where? From minus infinity to plus infinity, he will vary. So what happens if I replace s with minus infinite? Correct? If I replace s with minus infinite, what will happen here? Yes. If I replace s with minus infinite, so definitely what will happen? What will happen? This flow will diverge. So what happens if I replace s with infinite? No problem. If you replace s with infinite, I'll get 1 by e power infinity, which is equal to 0. It is converging, not a problem. But what happens if I replace s with minus infinity? This flow will diverge. And hence, what do we say? X of s converges for all values of s except at s equal to minus infinity. Okay, we'll write down that x of s converges for all values of yes, correct, converges for all values of yes except at when, except at s equal to minus infinity. So this implies what? ROC is what? Entire s plane except s equal to minus infinity. So this implies ROC is what? Entire S plane, correct? Entire S plane except where? Except at S equal to minus infinite. Okay, entire S plane except at S equal to minus infinite. Now let us take one more example. Now let us take x of t to be equal to delta of t plus 2. Now what will happen? So this is a Dirac delta function shifted to the left by 2 units, correct? So this fellow will exist at minus 2. Okay, so what will be our x of s? As usual, that is equal to integral minus infinity to infinity delta of t plus 2 e power minus st dt. So this again simplifies to e power 2s. Now what is that you notice? Okay, first let us write down what we got. Delta of t equal to x of t equal to delta of t plus 2 will have x of s, which is equal to e power 2s. Now tell me here, when will this fellow diverge? Yes, when will diverge in the sense when will x of s becomes infinite? Only if s is infinite. Okay, so x of s, what do we say? Converges for all values of s, correct? So for all values of S except at S equal to infinity. Okay, for except at S equal to infinity. Except at S equal to infinity. When you replace S with infinity, it will become e power infinity, which is infinite. Means our x of s is diverging. So what will be our ROC here? ROC is entire S plane. Again, correct? Entire S plane except at S equal to plus infinity. Okay, right. Now let us take one more example. Let us take combination of all these guys. Okay, what is that? X of t I take to be delta of t plus 2 plus delta of t plus delta of t minus 2. So how does the plot of this fellow look? So this fellow will look like this. Correct. So delta of t plus 2 plus delta of t plus delta of t minus 2. So what will be the Laplace transform? Our x of s, we can directly substitute, or we will do it integral minus infinity to infinity delta of t plus 2 plus delta of t plus delta of t minus 2 multiplied with e power minus st dt. So this we can easily simplify it as e power 2s plus 1 plus e power minus 2s. You can prove that result. Okay. Yes. So when will this flow converges? So this converges when you are for all values of s, I will say for all values of s except at where? When s equal to minus infinity, this flow would be 0, but this flow will become infinite. So we have to exclude that. When s equal to plus infinity, this flow will become infinity and this flow will become 0. So we have to exclude that also. So where should we exclude? Except at s equal to plus or minus infinity. So these two fellows we should not consider for region of convergence. So entire S plane except at minus infinity and plus infinity. Okay.